name is Fajimata Yusuf Fanarwa. I'm a student candidate in electrical engineering and computer science at Embry-Riddle University. Today I'm going to present you a crisis management through social media data software project management plan. So let's go through our agenda, which has an introduction, goals, which cover goals and objective, project scope, context, major constraint. A second section that we have, which is a project estimate, uh, where we cover the historical data used for estimates, estimation techniques, and applied or estimation technique applied, and the results, the project resources. And we have a third section which covers the risk management, the risk categorization, the risk table, risk mitigation, monitoring, and management plan, and a fourth section which covers the project schedule, where we designed our project Gantt chart using project, Microsoft project, critical path method analysis that we determine within Microsoft project also. And finally, we have a fifth section, which is the tracking and control mechanism. So the SafeMe system is a web-based software application developed solely to serve the purpose of crisis management system. It's like a system that will act as a central data manager, like collecting and analyzing all social media updates to help decision maker to monitor and provide assistance to higher risk sector in a more quick and efficient way during crisis times. So the project scope. The SafeMe project must gather requirements for what the project stakeholder required. So the purpose of SafeMe is to gather multiple social media data during natural disaster directly from a cloud data center, analyze and filter them before delivering them to first responders network. So the scope of this project consists of many components such as to follow the schedule and design requirement to deliver the application on time, to provide a user-friendly and secure platform for gathering and filtering data, and to connect also to a secure network transferring data to first responders network. So the major feature for SafeMe system administrator, for example, administrator should have a panel to display SafeMe environment control. They should manipulate data within a menu, and they can control all the collected data. Um, they can monitor the data centers panel. They can access live data from data centers menu. Um, they can also they can also see the location of data centers. They can back up data and recover and have access to a data recovery strategy. They can manage users and use within a security panel, or they can process that data and filter within a control panel. For the project estimate in our second section, so we used the Delphi estimate method, and we went through iteration with four member of the group. So we went through four round, and then we just define the estimation. All member, all four team member define their estimation within the four round, and then with our assumptions, and did, we selected five main tasks. We prioritized five main tasks that we just used for our first estimation using the Delphi estimate system. So our result came up with the first round, the second round, the third round, and the fourth round. And we have our first estimator who estimated the project at 715 hours, a second estimator 950 hours, a third estimator 1020 hours, and a fourth estimate 830 hours. And then so we proceeded to the second estimation, which is the COCOMO estimation 2. So we estimated our line of code at 11,200 line of code, and we used the COCOMO 2 estimation technique or line 2 to predict our cost, which came as a 56,560. The project was estimated at 19 months with an effort of 87% month, and the cost is $568,451. So with a total equivalent size of 11,200 line of code. So now we are our third section, which is the risk management. So we first um, identify the major important risk that may our project may encounter. For example, problem importing and spreading databases, like security breach during data transfer, SQL ingestion vulnerability, some unstable software requirement, unrealistic cost and schedules, external systems complexity and restrictions, issue with design implementation, some ineffective integration with vendor software, for example, and we define the probability of occurrence and the impact, and we get the risk value by multiplying the probability of occurrence with the impact. And then we we selected all the risk that have a risk value more than one, and made a risk analysis sheet with and made a risk sheet, risk information sheet. This is our example of risk number 3, which has a risk value of 1.2 with a probability of 30%. So we define this risk as being a critical because the SQL injection vulnerability may be critical since they are created by software that accept input from untrusted sources. Uh, and so we should not fail to properly validate and sanitize the web app-based application, the data, and use that data to dynamically construct SQL query to the database powering our application. So the refinement or context is like the potential attack vector for SQL injection may be our supporting main database. Also, the program may fail to sanitize the inputs via authorized and privileged user account. Also, the database may not have undergone proper SQL injection testing after design implementation. So the mitigation or monitoring was to create automatic detection of SQL injection vulnerability. Um, our programmer may create a testing environment to inspect current injection. Also include a number of tools for further exploitation, for further exploiting susceptible systems such as database fingerprint, data collection from compromised database, and access to the server's underlying file system. Also have database analysts attend 5 days training session on database management. Some management or contingency plan or triggers, so it were defined as to train our database analysts for 5 days in SQL injections. And the risk exposure cost is approximately 900. So the risk estimate was the probability multiplied by the cost of obtaining the training services from third-party providers. So we have to allocate this amount later into the project contingency cost. And our fourth section was the schedule. So we had we designed our work breakdown structure in order to determine our project schedule. So the work breakdown structure contains some task definition, task description, task owner, task dependencies, and predecessors, start and finish date of task duration. Um, and and then we estimated our work, the number of hour also per day of work estimate per day of work that are required to complete a task, the task status, also a Gantt chart, which is a chart to represent a visualization of the work breakdown structure with tasks represented graphically over the period of the estimated time. So this is our work breakdown structure chart. We first have the project management section that contains the software that is responsible to create the software team and perform user acceptance testing. The section for requirement should create software architecture document and the web interface design. The infrastructure section should be responsible for data centers requirement validation and setting up network protocols, security, and data centers connection. And the backend section is responsible for the backend and database development, develop backend security page, create media database, create data centers database, develop client management system, search for authentication provider, and Our last section within the work breakdown structure is the web application. To develop the web application homepage, create admin portal, search for authentication providers, develop the media library, and also perform the functional prototype, create the functional prototype. This is our result of our Gantt chart uh, that we had done through a Microsoft project. So we can see clearly this is the chart with the work breakdown into task and also by start date, finish, um, resources, also name, and also dependencies with precedence, task, and all all member that were required to work on each task. And our critical and we plotted our critical chart directly from Microsoft project where we have our critical path and identified our critical task design. So so basically um, our critical path our critical path is composed of the create software team, create a software architecture document, search for APIs, um, the data center's requirement validation, the back end and database development, the media database, and finally we have the task, which is the develop the media library. These are the component of our critical path, so they should be prioritized within our project scope. So this is the end of our project. Thank you for watching.